So we started 7.3 last time, and we are working on the last example. Just a reminder before we head to that, though, we actually had established some formulas for finding volume. They were based on the formulas for the volume of a circular cylinder, and we had these two different volumes, or two different volume formulas, and they were based on whether or not our radius, or our axis of revolution, rather, was a horizontal or a vertical axis of revolution. Okay, everybody good with that? And we talked about representing a rectangle of our image, and is our rectangle parallel or perpendicular? Do you remember? Parallel. This one's parallel, and we talked about it rhyming with the word shell is one way to remember that. All right, so we're on our last example here, example 3. We have used the shell method to set up and evaluate an integral that gives the volume of the solid generated by revolving. So we've got two equations, y equals x squared, and then y equals 4x minus x squared, around the line x equal 4. And you have done this image before. This image came about, did we do it in the last example? No, it wasn't on here. It was in the last section, wasn't it, on the homework? Okay. And so when you did this one, you started out by drawing the two shapes. And x squared, that's our typical parabola, right? So it looks something like this. And then 4x minus x squared, do you remember what that one looks like? It's upside down. It actually crosses right here and somewhere over here as well. So we've got another shape. I don't know how it ends. It doesn't really matter. The point is where it crosses. So it crossed at these two locations. We're revolving this around the line x equal 4. So we need to figure out where these two crossing points are in respect to the x equal 4. So do you remember how we find the two locations where they intersect? We set them equal to one another. So we would set x squared equal to 4x minus x squared. So what do we do to solve that? Put them all on the same side. I'm going to move them to the left just because that'll make my x squareds positive. So that will give me 2x squared if I add the x squared to the left, and then minus 4x equals 0. Then what do we do? Factor out a 2x actually, right? And that gets me x minus 2. So what are my two intersection spots? 0 and 2. So this one's at 0, this is at 2. So the line that I'm going to be using for my axis of rotation is actually a little further out. It's over here. Can't draw it today. There we go. X equal 4. And I'm going to be rotating like this around this line. So the shaded in area over here is my piece. We are going to shade those in my picture, but then I need to draw the representative rectangle, and will it be horizontal or will it be vertical? It'll be vertical because my axis of revolution is vertical. So that's that yellow piece right there. Everybody good so far? Okay. Now, if you'll remember, the formula that we have been using to find volume includes knowing the radius and the height. So let me write that in first. We've got some limits of integration, and then we have our radius, and we have our height, and we have times d something. And this is all in respect to what variable we're working with. So taking a look back at the picture, even without formulas and anything like that, you should be able to look at this picture and tell me what we're going to do this in respect to. That is, what is the width of this rectangle? Am I doing this with dx or dy? It is dx. And that's because the width of this little yellow piece that I drew in right here is actually with respect to x. So this is with respect to x. Your book uses an a and a b here, and then this is, of course, r of x and h of x, if we're doing it with respect to x. So we need a radius and we need a height, and everything's going to be in terms of x when we're done. All right, so taking a look, if we take a random point on our curve, and we'll just make it the top of that rectangle, the radius is going to be this distance right here, correct? What is that distance? Any ideas? Chelsea, you look like you have an idea, but you don't want to say. Guess for me.
Is it 4x minus x squared?
You're close.
4.
Okay, so it's 4. 4 is in it. We'll start with that. 4 is in it, yes. How do you know 4 is in it? Do you know how you know 4 is in it? Because that line is at x equal 4. Right. So, Jordan, you have an idea?
It's 4 minus 4x minus x squared.
You're close.
Well, the whole thing.
It's simpler than you guys are making it.
4 minus x squared. Is it just 4x squared?
Oh, man, you guys are still trying to make it so hard. It's 4 minus x. Let me show you. This distance right here is a little bit too low, but it's x. And the full distance here is 4, right? So the red distance that we're wanting is actually just 4 minus x. Okay, so don't be afraid to draw in some lines.
How do you know that that's x?
Yeah, that's what I was going to ask.
Because it's a horizontal distance. It's the distance away. Well, because this point right here, let me draw it in again. It's not exactly right, is the point xy. And a horizontal distance is x. So all of the answers you guys were giving me, we're going to use them, but we're going to use them when we talk about the height of this rectangle instead of the radius away from the axis. Because you guys are all giving me the y values. That's what you're giving me, right? That's what I was hearing a lot of anyway, was the y values in terms of x, of course. And we need that. We just don't need it for the radius. The radius is going to be the distance we are away from it. In this case, this is actually a horizontal distance, and horizontal distances are always x-valued distances. So this is actually 4 minus x for my radius. So let me just write these to the side for a moment, just identifying them. This is 4 minus x. We do need our height. Our height is a little bit more complicated, but if you take a look at the yellow, and I've got all kinds of blue markings now everywhere, but if you take a look at that yellow height, how can I find out the height of this rectangle?
4 minus x squared minus x squared.
And how do you get that, Chelsea?
The 2 lines that are
Not lines, but curves. They are parabolas in this case. So this goes back to 7.1. This is why we did 7.1. 7.1 was finding trapped area, right? And we talked about making these sort of a rectangular shape or looking at the top curve minus the bottom curve. And that's what we have going on here. This top curve minus this bottom curve is actually the height of my rectangle. The top curve has a height of y. The bottom curve has a height of, let's say, y2, a different y value. And we would subtract those two y values to find out the height of my rectangle. Those two y values are given in terms of the function up here. So those are my two. And the top one is the 4x minus x squared. So the height of my rectangle, I'm not going to have enough space over here. Let me move this a little bit. Is going to be the top height, which was 4x minus x squared, minus the bottom y value height, which was x squared. And we could simplify that, yeah? Sure. And in fact, it would be helpful to do so. What would this be? Good. All right, so in my formula over here, finding the volume, I am going to be finding, I'll find my limits of integration in a moment, the radius, which was 4 minus x, times the height, which is 4x minus 2x squared dx. What are my limits of integration? What are my a and my b in this problem? And how do you know they're 0 to 2? Yeah, it's the x values, right, back on this graph. And it's supposed to be the x values that bound the region that's rotating, right? So the furthest left x value is 0 and the furthest right x value is 2. So we're going from 0 to 2. And the setup is the hardest on these. That's why I want you to have time to practice setting these up. Because the integration for this is not going to be complicated. So what are we going to do first when we integrate this? Yeah, FOIL it out, simplify it before we start. So I need to distribute everything, or you need to distribute everything. So somebody tell me what I have.
16x minus 4x minus 8x squared plus 2x cubed.
Okay, 16x minus, what was next? I'm sorry, I think I wrote it wrong.
Sorry.
You want to do 4x next?
Well,
For my inside terms?
4x.
And then my outside terms would be a negative 8x squared. And my last terms would be positive 2x cubed. 4x squared right here. Okay. Did everything else turn out okay? Okay. Do you want to integrate?
That simplifies down to minus.
Yeah, that's what I would do next too. Let's simplify it so that we have as few as possible terms. So we have 16x. What else? Minus 12x squared plus 2x cubed. Polynomials. They're your favorite to integrate because you've been doing them the longest. So what is the integral of 16x? 8x squared. 12x squared becomes?
4x.
Very good. And 2x cubed? It is 1/2 x to the 4th, right? And we're evaluating this at 2 and 0 is one of our favorite numbers to evaluate in a polynomial. Why?
0.
Because they become 0 when we're working with the polynomials after integration, aren't they? All right, so we've got the 2 pi. We have 8 times 2 squared minus 4 times 2 cubed plus 1/2 times 2 to the 4th. And all of that would be subtracting off the 0 that we get if we plug the 0 in at the end. Nothing's showing up anymore, is it? Let's simplify. What do we have? In fact, you know what? Let me move to the next slide so that I can have just a little bit more space to work. In theory. Okay, did you simplify? What do you have? Let's do the simplification a little bit together first. So what's the 8 times 2 squared? 32. How about 4 times 2 cubed? 32. And then 1/2 times 2 to the 4th?
8.
Is 8, which gives me a grand whopping total of what?
16 pi.
16 pi. Very good.